the meter row with this. So we are going to be having this is how the experiment will look like. So first of all, we are going to be putting our pin. We are going to measure 20 degrees here. And then if you look at this 20 degrees, when we draw it, A, B, C, D, and it's going to look like this. So we are going to view it in between. You can see it. You can see the line, the two lines, 1, 2. But if you do shift it like you are no longer seeing it. So at this aim, we are going to put it at this line because we are seeing it here. We're putting it at here. We are putting it at here. At here. So this is what we are going to be doing. You can see it. It's at this line. You can see it. Though this one is bent, to be on the straight one. We are picking this. At this. So you can see that in this case it's okay. The video, the glass prism, hold it. So we are going to what test we're going to do, and then we're going to join it together. Remove the pin and join. We have called this one what? P1, P2, P3, P4. At this point where we draw, you can draw the right angle. Do first possible. This is actually what we are using to draw our right angle. And this is that normal N. And then the rate at which it meets here is called the angle of deviation. Touch here and what? And join. This angle of deviation. Normally, it ought to be passing here. The rate ought to be passing here. Ought to be passing here. But you can see in this case passes here. Pause. Experiment for 20, 30, 40, 50, 60 pause. To repeat this experiment for the second time, third, fourth, fifth time, and so on. So we are going to put it here. We now see the word A, B on a different sheet of paper. C, D, and then N. This should be what? N. This is 20. In this case, we can make it 30 or 35. Depends on what they gives you. This line should be in the line, the other line. It has entered. What should we do? In this from here to here is 5, 10, 20. So 30 should be here. 30 should be here. So in the case they ask you to do it at 30 degrees, here should be 30 degrees, and you join. So here. So this will not be what? 30 degrees. Incidentally. So they can't. Make sure your arrow should be here. If not, you are just drawing nonsense. This will be your incident ray. And so on. So what should you do? You are going to place it back and construct. You can see it. Then from the construction, one thing is going to be here, and the second pin is going to look through here at this line first of all, and then make sure it's balanced. So this is the pin. You can see that if you look at it through, we observe that if you bend the pin like this, you'll be seeing two pins. This pin and the other. If you do it like this, you'll be seeing until you fix it. Like in this case, you see that do it like this, you are seeing different pin until you see the two pins here. So in this case, you are seeing the pin. All the pins are seems to be one. Seems to be 1. Line. You can see. Put it here. If you do it like this, try to do it such that all the pin lines are the same line. So you can see the line. You can see the line. If you do it like you use your eye to see, you can see in this way they are balanced. So if you want to balance this ticket, it's going to be like this, with one eye closed. So you can see everything is now in one line. We remove. Though there was the line is already there, so it won't affect anything. So you can see. What should we do? This is our line. This is our line, and this is the point. You take it here, touch it, and then draw. You can see. So this is what P1, P2. You see the way P3, and what P4, and the ray should be at here. Should be at here. You can put it here and here. Here, and then draw a line. This is your end, the normal. So this ray should have met this one and this one. Touch first. Touch both. And you can see it. So therefore it ought to be like this. So you can see all these things. These are they ask to do for the angle of deviation. So this angle against any of this. So you know they may ask to measure this angle against this, or measure this angle against this. Or this, remember this is a refracted ray. This angle of deviation, and this is this. So they may ask to measure it for anything. This they may ask to measure this against this, or this against this, or this against this, or angle of deviation against this, using different formula, which is n equals to sine I over sine what r, which is Snell's law. And as to what defines Snell's law, the total internal reflection on what critical angle. So those are the three different things. Or what condition will a ray travel from what optical denser medium? Why will it move in this way, moving towards the normal? So which is from so they will ask you, which is from less dense medium to a denser medium. So it moves towards the what normal. Those are the questions they will ask you. What are the reasons? Although total internal reflection cannot take place here because from air to glass, but in this case, see that it moves away from the normal. So these are the various things they will ask you. They can ask you what is an incident ray is 30, sine n equals to sine I over sine r. N is 1 over 3, sine I is 30. What will be your sine r? You're going to calculate here and check if it's correct. Or they may ask to look for this one. These are the things they will ask you. Now look at this. This is on that and that one. You are going to shake it. They may put a mass at this. You are going to shake it first of all. So first of all, this is a mass. They will shake and they will count. 1, 2, go. 1, 2, 3, 4, 5. Sorry, let's go again. It's supposed to be like this. 1. You can see the way I hold it. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Though I did it for 11. I've done the value before 12. Look at the value I did on the board. So those are very same thing. Which is what? This is when the length was about 40. When the length was 40. But let me do when the length is not 30. We are going to check how many oscillations is going to be. We are going to check how many length is going to be. We are going to measure it and see if it wants to bend. So you can see at this length it's going to be. So okay. So what I'm going to do, we're going to hold it from here. We can go to the deviation. So with our time, with our stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Our stopwatch, the time is going to be 14.389. We are repeating the same experiment again to give 14.489. So we are just, let us find the new length. Let's see the new length here. I gave you something, make sure you finish my work. We are going to 1 to go. 1, 2, hold on. There's no straight in. 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. Pause. So I'm going to check the length. The length is going to be this. Repeat it second time. Repeat second time, we're still going to get this before we adjust the length again. So I'm going to get it a little bit closer, and then we're still going to take our reading. Pause. Trial and second trial divide by 2 this. First trial and second trial divide by 2 this. When the length is what? At 30. First trial and second trial length is going to be this. When the first trial and the second trial is going to give you this. When the length is at 50, the first trial and the second trial is going to give you this. Then divide it by what? 20 to get 20 oscillation. So you're having 20 divided by 20 gives you this, 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 divided by 20 gives you this. So these are various things. So we know it's difficult for you to plot on your graph because they will tell you find the length against the corresponding time, or the length against the inverse of time, because they may ask you against the inverse of time, which is 3 raised to the power minus 1, in case they ask you. You can see what you now do year to year as 1, in between, plotting graph in between here, to be so difficult. So what will happen, they may extend it, which is now you're going to convert this to what decimal point to standard form. It can be 8.25, then you put it as 10 raised to the power minus 1. If you want to make it to become 82.5, 10 raised to the power minus 2, but we're using 10 raised to the power minus 1, so it will be 8, 7, to be 8.27, 0.773 will now be 7.73, 0.721 will now be 7.21, 0.660 will now be 6.60, 0.615 will now be 6.15. So I'm going to plot it. They can tell you of height of the length against what? The corresponding distance, which is length against distance. So you're going to plot it here. In this case, you know that you can do 2, 4, 6, 8, 10. So in between 6 and 8 will be here. So you can see that the graph is going to be very big in this case. So these are, so in between the length can be the experiment can be either this or this. Remember that this one is for the vibration. For this vibration, when you are asked to do something of this nature, any of these two can come out. When you are asked to do any of this nature, one. So that. But now, look up. The second one is that. So the second one is that what? For this length, they'll tell you when it's at 10. So when it's at 10, you can remove it here and put it at, first of all it was here, put it here, it was 5, give the distance of 5, they'll ask you to put the length here will be 5, and here will be what? 95. So in between here to here, from here to here will be what? 5, so that it will be at what? 95. It should be at 95 here. So what happened? So in between, that means the distance is going to be what? 90. The distance is going to be what? 90. So this time is going to be 90. We are going to put it at what? They say at 10. 10 plus 5 is going to be at 15. So it will be in between 14 and 16, which is 15. In between 14 and 16, which is 15. We put it here. So when we put it here, we are going to mask it. And mask it. When we are done masking, before masking, we are going to take the initial length. Before masking, we are going to take the initial length of this. Check the length in between here to here, from here to here, from here to here. In between the length here to here is going to be about 14. You can see 14. So we are going to put it at 14. Take notes. As someone should put 14 for me. And also from here to here, the length of the spring should be about. Should I say? Length of the spring 20. Let's start it from here. 29. So 14 plus the total length should be about 14 plus 29 should give us what? 14 plus 29 is about 41, yes. 14 plus 29, add it. 14 plus 29. Wait now. Do you see what? Pause. What? 43. So you can see that's about 43. Probably we leave it here like this. It's about 43. See it here. It's about 43 here.
Let me check the view now, I'm guessing.
So when you see that it's 43, what are you going to do? Then we are going to put it down. But in this case, we showed 42 there. We showed 42. So when I did it first time, it was 42. So we adjusted it again. So what should we do next? What should we do next? We are going to put the load at, remember it was 10. Check 10. When the load is at 10, 10, control. So 10 plus 5 is going to be 15. This is when the load is at 10. It's going to be at 15, in between 14 and 16. In between 14 and 16. Length at this is going to give us so the length is going to be raised up at 41.5. 41.5. So you check there, you see that's what at 41.5, and then what we are going to put it at 50. Show this one. When it was 5 plus 20 gives you about 25. So 25. So it should be in between 24 and 26.
3.
So it should be in between 24 and what? 26. Remember? Move it to that side. That's it. We did show this way. We did 20 oscillation and keep the time. But this time we are not going to do 20 oscillation. We are going to check what? In this second one, we are going to be increasing it and be checking the length. We are going to be checking the length, the corresponding length at which it should be. So you can see, and you see that the length is at what? 42.5. It's at 42.5. So we are going to observe, we are going to put it there. This is how we keep on doing. When you keep on increasing the length, you see that what? When you keep on increasing the length, you see that what? The meter rule will be what? Coming down. And see, when we keep on increasing the length, you see that what? The length is coming down. Keep on increasing the length, you see that length is coming down. To an extent whereby it may be out to 50. You can see that it has come down more. So you are going to check about the length. You are going to calculate the length of this, of the spring with the what? Corresponding what? Height. With the corresponding length of the each mass, because each mass should be at least 100 grams. 100 grams when it's at 10 centimeter, 100 grams when it's at 20 centimeter, 100 grams when it's at 30 centimeter, 100 grams. So we are going to what? Plot a graph. So all these are the things they will do what? Ask you to what? Do. So make sure you pay total what? Attention. For this, it's going to be on a different day. So we may not be able to construct all these things again. If not, we are able to do what? Construct all these things. So take note. So, but for electricity, that will be what? Another day. You can conduct electricity next time. So that's all for today. This is the Desperado channel. Bye for now. So, bye for what now? Okay,